Good morning. Now the topic is spin modulator in microwave and optical engineering subject. Okay. What is a pin modulator? It's pin modulator is nothing about a pin diode consists of heavily doped P and N region separated by a wide intrinsic regions. P is junctioned as WP with the width WP, whereas N junction as WN, I is an W width. That is a it is heavily doped intrinsic with a wide regions, that is I is majorly component. Okay, by the diagram we are seeing about VR is a voltage applied. Intrinsic region offer high resistance to the current through it. The wide intrinsic region makes the pin diode an interior rectifier, that is inferior rectifier, one typical function of a diode, but it makes the PN diode suitable for attenuator, fast switches, photodetector, and high voltage electronic application. PIN diode work as an ordinary PN junction diode frequency up to a 100 MHz. Above 100 MHz is sees its operation of rectifier and behave as a switch or resistance. In reverse bias, it acts as a capacitor. So, in reverse bias, it acts as a capacitor, whereas in forward bias, it will act as a switch or resistance. See how the things will be matched here. The PIN. Top layer is a top metal contact. Next is a P plus contact region. Then is a P diffusion region. Then is a intrinsic region, that is large depletion region. N type and N plus contact region, and bottom is a metal contact. It is a pin diode modulator. Structural formations. Okay. Biasing of pin diode. Unbiased. First of all, it is a by unbiased and forward biased and will be okay. When pin is unbiased, there is a diffusion of electron across the junction. Depletion region is formed between Pi and In with more penetration into intrinsic region. When pin is unbiased, there is a diffusion of electron from the junctions across the junctions. Forward bias. Whereas in forward bias, when the diode is forward biased, when the bias is forward biased, the injected carrier concentration is typically several order of magnitude higher than the intrinsic level carrier concentration. Due to this high level injection, which in turn is due to depletion region, the electric field extends deeply, almost the entire length into the regions. The electric field help in speeding up the transport of charge carrier from P to N region, which result in faster operation of the diode, making it a suitable device for high frequency operations. IN forward bias of diode behaves as variable resistance, and resistance decrease with increase in forward bias voltages. When the variable resistance in forward bias, it is represented as in diagrammatic representation. See, whereas in reverse bias, as the reverse bias already said, it is a capacitor, act as a capacitor. So voltage is increased, depletion area thickness increases. The device behaves as variable capacitor until the intrinsic region become free of mobile of carriers. This voltage is called a swept out voltage. At this voltage, the device works as a constant capacitor. Applications. See, RF and DC controlled microwave switches. RF and DC controlled microwave switches. See, RF is nothing about radio wave frequencies. DC controlled microwave switches. See how the application is totally uh, changed in this kind of pin modulations. DC control switches. See, DC control switch means resistor capacitors will be the DC control switches that has acted here, and also it has used as radio frequencies, microwave frequencies. See how complicatedly we are using those things. RF and variable attenuators. RF and variable attenuator. What is an attenuator? It is nothing about it's a resistivity of powers. The resistivity of powers mean the it's nothing about the power has been reduced, not by the resistance, it's just by the attenuations factor. Okay, AC, DC, like this we are representing. No, in those things we are seeing about the attenuations, that is microwave components only. In limited circuits, it will be used for limiting of things will be used out. Photodetector and photovoltaic cells, RF modulator circuits, those things will be applied and applications are used out. Okay, thank you.